So in the previous tutorials, we have looked at how we can apply the integral test, the limit comparison test, as well as the ratio test to determine uh, the convergence of a series that you're given. Okay, so make sure to say you watch until the end so that you don't miss any point that might be relevant. And just in case you're new to the channel, don't forget to subscribe, um, leave a comment down there in case of anything, as well as share the content. Okay, so let's say we are given a series from n is equals to 1 to positive infinity of a sub n. Okay, so let's say we're going to determine the limit as n approaches infinity, okay, of the nth root of the absolute value of a sub n, which is our series. So if this is equals to L, so this L that we are going to get is the one that's going to help us to determine the convergence of a series that you have. Okay, so again, like, it's not always that it's going to converge. Sometimes it's going to diverge, and sometimes, like, we are not able to make a conclusion because of what the value of L is. All right, so there are three key points that we have to keep in mind as we when we get the value of L. Okay, the value of L that you're going to get, from there we're going to make a conclusion whether what we have converges or diverges, and if it converges, to what value does it converge to. Okay, so if it diverges, it might be some value, but we're going to understand that better, or it might be possibly infinity, because let me even start with divergence itself. So if our L is greater than 1, we need to know that our our series, okay, our series A sub n diverges. Okay, so anything greater than 1, it can also include infinity. It can be 1.1, or anything from just anything greater than 1. It can be something like maybe what from 1.00, maybe 9. This that is still greater than 1. Okay, so the only value that here is not included is 1. Okay, so anything greater than 1, we're able to say that the series that we have diverges. Okay, so there's another condition when our L is less than 1. So that means our series A sub n, that runs from n to infinity, we're going to say it converges. Okay, so that converges. So the value of L that we're going to get, we'll be able to make an interpretation from that point there to say, okay, do I have something that is less than 1 or greater than 1? Then if our L is equals to 1, okay, if our L is equals to 1, of course running from n to infinity of the series A sub n, this one, we can't really make a conclusion here. I'll just say no conclusion. Okay, we can't really make a conclusion for that one. All right, so let's try to look at some examples. We try to reason from what this statement, so that we determine what the convergence is. Okay, and we want to see how we are able to apply. So let's say we have the series that runs from n is equals to 2 to infinity, or then our a sub n is a rational expression that is 1 over uh, natural log of n. Okay, natural log of n to the power n. Okay, so what we're going to do here is we're going to say the limit as n approaches infinity of the nth root. Okay, I'm not saying square root, I'm saying nth root. So you have your n here. Okay, so you have your 1 divided by uh, your natural log of n, your natural log of n to the power n. Alright, so what you observe here is that we can also write this in the form, we can say the limit as n approaches infinite. Then I'm going to say open bracket 1 over uh, natural log of n, natural log of n to the power n. Okay, then we are going to raise that to the 1 over n. Okay, so right here we have reached, we can distribute the 1 over n to 1 over n to the numerator, which is 1, as well as the denominator, which is a natural log of n to the power n. So you observe to say 1 raised to anything is still 1, and what you have here, what we have there is like what you're going to have, what we're going to have here, if we say 1 to the power 1 over n, it's more like you're saying nth root of 1. So regardless of what our n is here, this is still going to be a 1. Okay, that is still going to be a 1 there. So we can say for that one, it becomes the easiest. You can say it's the limit as n approaches infinity. That would be a 1 divided by so we distribute the 1 over n to what you have here on the denominator. So we can say this is going to be n multiplied by 1 over n. So that and that is going to go. So just going to remain with a natural log of n. So that would be like ln of n, like that. So if you substitute here, okay, if you substitute, you observe to say natural log of infinity is going to give you a 0. Okay, so we observe to say our L is equals to 0, and our L is less than what? Is less than 1. Hence we can say I can say hence the series that runs from n is equals to 2 to positive infinity. Positive infinity. Okay, I'll just say a sub n. I'll say it converges. So the key point is just to find what your L is, and after you find your L, you make an interpretation by you having that knowledge of to say, okay, is my L less than 1, or is it greater than 1? So let's try to look at another example. Let's say you have a series from n is equals to 1 to infinity. Then it's also a rational expression. Let's say 2 raised to the n plus 1 divided by n to the power n. Okay, so I'm going to say the limit as n approaches infinity. I'm just going to write this as 2 to the n plus 1 divided by n to the n raised to the power 1 raised to 1 over n there. Okay, so this we can also write it as limit as n approaches infinity. So we'll try to distribute the 1 over n on the numerator as well as on the denominator. So this is going to be, if you distribute that, that's going to be 2 to the power n plus 1 divided by n. Okay, then this one's just going to be n, because you have your n here multiplied by 1 over n, that would be n. Okay, so how can we then write this? How can we then write this one? So we can say this one, we can say the limit as n approaches infinity. Okay, I can simplify, I can say 2 to the 1 plus 1 over n is still the same as that one there. So I'll say divide by n, like that. Okay, so what do we have now? So this is more like saying the limit as n approaches infinity of 2 multiplied by 2 to the 1 over n divide by n there. Okay, divide by the n. So how are we able to simplify what we have? Okay, so we observe to say this is more like the limit. Okay, the limit as n approaches infinity of I think even just the way it is right here, we observe to say there's really nothing much that we are able to do on the denominator there. Okay, there's nothing that we're able to cancel out with, such that we try to compensate the n that we have on the denominator to prevent it from the expression being 0, because immediately we substitute with infinity there, everything is going to become 0, because I can say, okay, I can write it as let me say if we say 2, okay, then we put 2 to the power 1 over infinity divide by infinity. This one here is going to give us 0, rendering this one to be what? To be a 1. Okay, so that would be like 2 to the power 0, that would be a 1. So remember to say we are going to have 2 divided by infinity, of which 2 is way too small and infinity is way too large, meaning this one is going to be 0, and this is our L, which means it's less than what? Less than 1, and we can conclude that um, our series, our series A sub n, that runs from n is equals to 1 to infinity. You can say it converges. It converges there. Okay, so it's not always the case that it's always going to converge. It depends on the series that you are given. Okay, sometimes it may diverge, sometimes it's going to converge. The only key point here that you have to keep in mind is that you just have to know to say when does it converge and when does it diverge. Like, what should be my value of L for me to conclude that it diverges, and what should be my value of L to determine that it converges. Okay, so to just remind ourselves again, we've said if L is greater than 1, then it diverges. If L is less than 1, it converges. If L is equals to 1, we can't really conclude here whether it diverges or it converges. Okay, so this is where the whole thing lies. Okay, if we know this, it's going to become much easier to solve some questions, because it's just a matter of you finding your L. Then after you find your L, you're able to make a conclusion from there. Thank you very much for watching.